We've looked at a lot of bits and pieces involving volume of cuboids. We've looked at volumes of compound shapes as well. We've looked at volumes of prisms. What we're going to do now is take a lot of those things we've learnt and apply them to some problems that you might face in real exam conditions. So here's a simple thing. A cuboid has a square base and is 3 times as tall as it is wide. If its volume is 648 centimeters cubed, what is the height of the cuboid? The first thing to do with a question like this is to draw the diagram. It's a cuboid. It has a base that is square, and we're told that the height is 3 times the base. So the base of this cuboid is square, both sides are x, and the height is 3 times the base width, so that's 3 lots of x. So now we've got our diagram of our cuboid, and all of the sides are labelled. We know that the volume is 648 centimeters cubed. So the cross-sectional area of this prism, which is what it is x times x, so that's x squared. And so we know that the volume is x squared times 3x, which gives us 3x cubed is equal to 648. Divide by 3 on both sides, we get x cubed is equal to 216. And take the cube root of 216. You might know that is 6 centimeters, or you could put it in your calculator and work it out. So we know that x is 6 centimeters. We were asked for the height of this cuboid, and the height is 3 times the base width, which is 18 centimeters. So no startlingly difficult maths in there, just being able to take the very small amount of information that's in the question and turn it into a diagram. And the key here is having drawn the diagram. Once you've drawn that diagram, the question becomes very simple to answer. Okay, let's look at a more tricky question. We use a cylinder this time. The volume of this cylinder is 286.2 centimeters cubed. Its length is 10 centimeters. If pi is 3.14, what's the radius of this cylinder? So we're going to have to work backwards from the volume to get to the radius. Let's draw the diagram. We draw our cylinder. You don't have to be brilliant at art to draw a cylinder. It's 10 centimeters long, and we'll put on there the radius. That's what we're trying to find. A cylinder is a prism, so the volume of the prism is the cross-sectional area times the length. The cross-sectional area of a cylinder is a circle, so the area of the cross-section is pi r squared. So in the case of this cylinder, we have the volume is pi r squared times 10, which is the length, equals 286. We're just going to use 286 here. We're going to not worry about the 0.2. Divide by 10, we get pi r squared is 28.6. Divide by the value of pi we have of 3.14, we get r squared is equal to 9.1, which gives us our value of r by taking the square root of 3.02 centimeters. Again, not spectacularly difficult. Once you've realised you have to work backwards from the volume to get to the radius, drawing the diagram helps you realise it's a prism, and you just have to make sure you understand that the cross-sectional area of a cylinder is a circle. And then you can go and remember that the area of a circle is pi r squared. Once you have all that information together, the question's quite straightforward. Let's do a third and final example. This time we have a triangular prism. And the triangular prism has a base or a cross-sectional area that's an isosceles triangle. So the two equal sides of the isosceles triangle are 5 centimeters and the base is 8 centimeters. The volume of the prism is 180 centimeters cubed. You're asked to work out the length of that prism. This is not dissimilar to the problem with the cylinder. We have to focus on getting the cross-sectional area. To do this, we're just going to look at the triangle from the side, and we're going to take half of the isosceles triangle. Because it's an isosceles triangle, we know that the base of the half triangle, which is the right angle triangle there on the right hand side, is 4 centimetres, because it's half of the 8 centimetres. We can use Pythagoras' theorem to work out the height. By rearranging there, we get x squared is 5 squared minus 4 squared, so x squared is 9, so x is 3. You might remember this as a 3, 4, 5 triangle. If you do, you can avoid using Pythagoras at all and go straight to the value of 3 for the height. The cross-sectional area, therefore, of that triangle is a half times the height times the base, so it's a half times 3 times 8, which is 12 centimetres squared. So let's get rid of all of the additional pieces of information we've written down and just go back to the original diagram. We know the volume is 180 centimetres cubed. So cross-sectional area times the length is 180 centimetres cubed. We've worked out the cross-sectional area, that's 12. So 12 times the length is 180. So the length is 180 divided by 12, which means we get our length of this prism of 15 centimetres. As with the cylinder example, we've had to work backwards from a volume to get one of the values of the dimensions of this prism. The extra trickiness involved in this particular example was having to work out the height of the triangle using Pythagoras in order to work out the cross-sectional area before we could use that to work out the length. Again, it's about knowing how to do the simple little things in the correct order that gives us the correct answer. And as usual, one key to that is making sure we write down all those intermediate steps along the way so that we don't lose track of what we're doing. That way, you're much more likely to get the answer correct.